Hello guys, welcome back to mathematics. You are being taught polygons today by teacher Joel Musivi. Welcome back to this YouTube channel. Continue supporting to me. Make sure you watch the whole video out to the last minute. Make sure you support me by subscribing, commenting, and liking my video. Today we are looking at polygons, angular polygons, and specifically we will be looking at naming the polygons by the number of sides the polygon have. Then also, as you use the sides to name the polygon, we'll also look at the number of sides the polygon has by using those sides, and also we'll be able to calculate the sum of the interior angles the polygon has. Then we will look at a few examples regarding the polygons. So welcome, feel free to comment, feel free to connect with me for more lessons. So now here, as you know that a polygon is a figure joined by 3 or more lines. So therefore, the number of sides is also equivalent to the number of lines joining to make the polygon. So now we will start by naming the polygons. Here you can see the number of sides is referred to as n. We have a polygon with 3 sides, 4 sides, 5 sides, 6, 7, all the way up to 10. So we will start by naming them. Then you can see in this section we will have the number of triangles. The number of triangles is equivalent to n minus 2. So where n is the number of sides. So to get the number of triangles, we'll just take n minus 2. Then the sum of the interior angles, we know each triangle has 180 degrees. So we will just take the number of the degrees a triangle have. Then we will just multiply by the number of triangles that we've already got here. So that is the procedure. So now if we have a polygon with 3 sides, the prefix for 3 sides is always tri. Then now we will name it as triangle. Triangle. To get the number of triangles this triangle have, it is simply you take the number of sides, then you subtract 2. So it will be simply 3 minus 2. And you realize that a triangle has only one triangle. Then to get the sum of the interior angles, we will say it is 180 into 3 minus 2. 3 minus 2 is 1, so you will get a triangle as the sum of interior angles as 180. Then go to the second one, which is 4, and the 4 is represented by quadrilateral. Therefore, we call it a quadrilateral. A 4-sided finger is a quadrilateral. Remember, we have several figures with 4 sides. We have the rectangle, the square, the parallelogram, the trapezium. All of them, we name them as quadrilateral. The number of triangles, we'll just say the number of sides is 4 minus 2. And you get simply 2. Then now, the sum of interior angles, which is always given by 180 into n is 4, then minus 2. Then this will be 180 times 2. You get the sum of the interior angles is 360 degrees. We move to the fifth polygon, and the 5 comes from the word pent. Then now we have pentagon. Pentagon, the number of triangles, we'll say it is 5 minus 2. You get 3. You get it 3. Sum of the interior angles, it is 180 into number of sides is 5 minus 2. And it is 180 times 3. You get 540 degrees. 540 degrees. The sixth one is hexa. Can call it hexagon. Hexagon. And hexagon has 6 sides minus 2. You get simply 4. So it has 4 triangles. And you can say 180 into 6 minus 2. Here it is 180 times the 4 triangles. Hereby you get 720 degrees. You get 720 degrees. Then we have a polygon with the 7 sides is called an heptagon. So an heptagon has 7 sides, then minus 2, you get 5. So it has what? 5 triangles, meaning if we apply the formula for getting the sum of the interior angles, we will say it is simply 180 times 5, which is 900 degrees. Get 900 degrees. Then a polygon with 80 sides is octagon, meaning it is 8 sides minus 2 to get 6. To get 6 triangles. Therefore, we apply the formula for finding the sum of the interior angles of a angular polygon, and you will have 180 into 8 minus 2, which is 180 times 6, and you get 1080 degrees. That is for octagon. 9 nonagon. 9 is called a nonagon. So a nonagon has 9 sides minus 2 to have 7 triangles. Therefore it is 180 into 9 minus 2, which is 180 times 7. You get how many? 1260 degrees. 1260 degrees for a nonagon. Then for 10, a 10-sided figure is called a decagon. It's called a decagon. And a decagon has 10 sides. Then you subtract 2 to have 8 triangles. Then you can say 180 into 10 minus 2, which is 180 times 8. You get 1440 degrees. So in whole sum, you can realize that a 3-sided polygon is called a triangle with interior angles 180. A 4-sided polygon is called a quadrilateral with 360 degrees. A five-sided polygon is called a pentagon with 514 degrees is the sum of the interior angles. Then a six-sided polygon is a hexagon with 720 degrees. Then a seven-sided polygon is called an octagon with 900 degrees. Then eight-sided is called an octagon with 1080 degrees. Then a nine-sided one is called a nonagon, which has 1260 degrees. And the last one that we will look at is the decagon with 1440 degrees. These formulas are very important for the number of triangles and the sum of the interior angles. So if you look at this, we consider the prefix is tri, quadri means 4, pent is 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and dec, which comes from and decade means 10. So with that, we have known that we can be able to name the polygons according to the number of sides a polygon has. Now we now go to scenarios whereby we can now try to solve some of the examples which comes from the solutions of associated with the polygons. So here we have example 1. Example 1 says the sum of the interior angles of a angular polygon is 1440. Find the number of sides the polygon has, the name of the polygon. So let's look at this question. This question, the keyword here is the sum of interior angles is 1440. We calculate the number of sides the polygon has. So here we know the formula for finding the sum of the interior angles of a angular polygon is 180 into n minus 2. That is the formula for finding the sum of the interior angles of a angular polygon. And if you apply that formula, you should get 1440 degrees. So you equate the formula to the sum of the interior angles. Now, the number of sides is always represented by n. So when we equate this one, we are going to try to find the value of n. So we start by opening the bracket. So we have 180 times n, you will get 180 n minus 180 times 2, you get 360 is equal to 1440. Now we want to remain with 180 here, so you will take this 360 to the other side, putting the like terms together. So I'll have 180n is equals to 1440 plus, this was negative, when it crosses the equal sign, it becomes positive, so plus 360. So it is 1440. You divide with, you want 360, and you are going to get 108n is the same as 1800. So 108n is equals to 1800. You want to remain with n here, so you divide by the coefficient, which is 180, then divide by 180. So that one and that one goes, you remain with n. and this one and this one goes by 18 1 by 18 1. You get 10. So this polygon has 10 sides. So the polygon has 10 sides. The name of the polygon. So a polygon with 10 sides, a polygon with 10 sides is called an decagon. Polygon with 8 sides is called what? An decagon. We go to part C of our question. Still looking at the same question. The size of the interior and the exterior angle. So we start with the interior. So the formula for finding the size of the interior angle is given by 180 minus 360 over n, where n is the number of sides. N is the number of sides. So this is the same as 180 minus 360 over. We have seen that the polygon has 10 sides, so we'll say over 10. So this is simply as 180 minus 36, and you will get 144 degrees. Then we calculate the exterior angle. The formula for finding the exterior angle is given by 360 over n. So this is the angle, this is the angle. 360 over n, which is 360 divided by the 10 sides. And you get the exterior angle is just 36 degrees. You will realize that both the exterior and the interior lie on a line like this, and angles on a straight line and up to 180. So if here we have the interior, then this one is the exterior. So if you get the interior, you can just subtract from 180 and get the exterior. Now, part D of the question is the number of triangles the polygon has. You all know that the number of triangles is given by n minus 2, where n is the number of sides. So our polygon has 10 sides. You subtract 2, you get 8 triangles. Get 8 triangles. So that is all about that example 1. We want to look on another example 2 here. Example 2, which reads like a certain polygon has 7 sides. Calculate the sum of the interior angles. A certain polygon. So we look at the 7 sides. So the 7 sides means n is equals to what? 7. Remember, the number of sides is represented by n. So we are looking at the sum of the interior angles. So the sum of the interior angles is always given by 180 into n minus 2. And we already have what? N. So it will be equal to 180 into n is 7. So it is 7 minus 2. And therefore, we'll have 7 minus 2 is 5. So we'll have 180 times 5. 180 times 5. So if you multiply 180 times 5, you get 900 degrees. So the sum of interior angles of a angular polygon with 7 sides is 900 degrees. The size of the exterior and the interior angle, we start with the exterior. To get the exterior is 360 over n. And n is 7, so we will have 360 divided by 7. 360 divided by 7. In this, you can try to use a calculator or use the long division method. If you use long division method, you can have 51 point. You can have 51.4 degrees. If you want the interior, which is simply 180 minus the exterior, because 360 over n gives us the exterior, we'll have 180 minus 51.4. So 180 minus 51.4 using the long division method. The long subtraction method. You are going to have 128.6 degrees. 128.6 degrees. Then you are also required to name the polygon. So this polygon has 7 sides. The polygon with 7 sides is called an heptagon. It's called an heptagon because you said hept means 7. So we come to in conclusion to our class about the polygons. Next time we are going to solve more examples on polygons. Remember to subscribe, watch, comment, and like my videos. I also have other platforms. You can follow me on TikTok at DoctorJoel Musivi. You can call me on Facebook, still DoctorJoel Musivi. I'm also in Instagram, DoctorJoel Musivi. You can also follow me links on WhatsApp. I have attached links on WhatsApp. If you have any learner who needs assistance, they can follow me or contact me on my WhatsApp account. I've left my link there below. Continue supporting me, and I'll really appreciate